Welcome to those of you that are starting to join for today's session. We'll get started here in about 2 minutes, 2-minute warning. Thank you. We're going to get started here in about 30 seconds or so. So thank you for everybody who's joining, and we'll get started here in just a moment. All right, so let's go ahead and begin. So welcome to today's session. Thank you for attending. My name is Josh Brolfheim. I'm the training manager at Sumo Logic, and I'm going to be leading today's session. I have one of my peers, Odell Gordon. He's going to be answering the chat. So throughout today, if there's any questions, go ahead and put them in the chat and he'll answer them, or we'll bring them up to the larger group, depending on what's appropriate. Let's go ahead and dive in. So we're going to meet together for the next 3 hours. I don't know if you've taken one of our certification courses or not before. Hopefully you have. You probably have, actually, if you're taking this course. If you haven't, that's fine. But it follows a very standard format as our other courses. So we're going to be together for the next 3 hours. The first 2 hours are going to be devoted to the content, primarily labs. This is going to be a pretty heavy, lab-heavy day. And then we'll set aside that last hour for the exam, and we'll get into the exam as we get closer to it. Like I mentioned, if you've taken an exam with us before, you kind of know where we're headed, but certainly that's going to be the plan for today. So that's the game plan. Any questions, put in the chat, like I mentioned, and we'll get in there shortly. I have a little demo that I'll do to start with, a slide or two, and then we'll really get into labs pretty quickly. Along with the introduction, maybe one of the more important features of today's training is bribery. So I'm saying that joking, of course, but we wanted to reward you for taking today's class. Typically, we would do these classes in person and we'd feed you and give you a t-shirt or something. Well, we can't really do that right now, so we came up with an alternative method. So once you take the exam today and pass it and send your certificate to Sumo, to training-promotions@sumologic.com, we'll give you a $15 Uber Eats card. So I'll go ahead and remind you of that promotion later. All you need to do is send that certificate with your work email or from your work email, and we just need your job title, and then we can take care of that for you. So a little motivation to make it through today's class. Sumo Logic Continuous Intelligence Platform, easy for me to say. Essentially, we can help you with a variety of different aspects of your business: operational intelligence, business intelligence, et cetera. Well, today we're really focusing on security intelligence. So how can you use Sumo Logic to garner or gain security insights into your data? That's what we're going to be doing today. So, of course, your data needs to be brought into Sumo Logic. So in order for us to assist you, or the system to assist you with anything, you need to bring your data into Sumo Logic, regardless of where your data is. It might be in the cloud, it might be in the server, it might be on your laptop, it might be a few other places. And that data ultimately needs to come to Sumo Logic. Now, once it's in Sumo Logic, then you can start to use our analytics to go ahead and start to analyze your data using some of the advanced analytics. And we're going to look at some of those operators today. Using APIs, which we won't do today, but fully functional within the environment. Machine learning, security and monitoring. All the environments have multi-tenancy and are scalable and elastic, so they can grow with you as well. And then fortunately, everybody can use Sumo. So while you might be part of the security focus, you might be part of customer success. You might be an eng guy, a DevOps individual, whatever, and everybody can use Sumo. Now, focusing on the security intelligence side of Sumo, there's three areas where Sumo could help. The first one on the far left is audit and compliance. And so you can utilize Sumo to make sure you are compliant. We have some built-in compliance apps where you can show your collection and ingestion to see what you're bringing into Sumo, which for an auditor is going to be important. There's the security analytics side of things, and that's where we're going to be focusing on today, is that middle column. So we're going to be going over searches and dashboards and alerts, then advanced analytics. And as I mentioned, some of those advanced analytic operators. And then on the far right, we have our Cloud SIM product. Additional product, great features, works great for threat correlation, workflow with event management, as it says. We have a separate class for that. Totally encourage you to take that, but that's not the focus of today. Today's focus is the middle panel or middle column. And more specifically, as I said, searches, dashboards, and then advanced analytics. And all of them together are going to give you a great insight into your environment. All right, quick little demo. This is going to be pretty fast. Not fast, but there's just not much to it. It's a couple panels, but I do want to show it to you because it's pretty helpful. And it gives a good example, or I guess you could say example of what we're about to do today. So what I have here is I've logged into Sumo Logic, which hopefully you've done previously. If not, this is what Sumo looks like. And I've created a security view. Maybe I created it, maybe my manager did, maybe somebody else did, but regardless, I have this view. And what the security view is showing me is exactly what it sounds like, a view into my security and seeing what's going on. And well, let's start to look at these panels and see what they show us. So the first one right here, SSO and non-SSO login location. So what I'm seeing is over the last 60 minutes, I'm seeing where in the world people or computers or systems have logged in from. Why as a security individual might this be important? Well, it might be relevant to know where people are logging in from, knowing where your people are based, and then seeing if there's any variance and possibly trying to understand what's going on. Let's say you are a US-based company, good old USA, and you're really pretty US focused. You don't really do much business outside the US. But you see here in these login locations, you see people logging in from Africa and South America and all over the rest of the world. Now, if you do not expect that, this could be quite concerning. Are these hackers? Are they trying to break into your system? Maybe, maybe not. But if you start to go down the route of figuring out who these individuals are, maybe it becomes understandable. Maybe somebody is US based, but you know what? They're on vacation in Africa and they're doing some work. Maybe there's somebody based in the US that is doing VPN testing around the world and they're egressing from all these individual spots and it's showing up as people coming in, but in fact, it's someone just doing kind of penetration testing for you. That's where you can take the data and sort of digest it. So we can show you here that who's logging in or where they're logging in from, but then you need to kind of put on that security hat and decide, is that appropriate? Is that a problem? And so we'll play with this, this map and this feature in the labs. It's really easy to set up and really helpful. Threat intelligence right here. What we have is a system scanning IP addresses. And what it's found is over the last 60 minutes, I'm trying to highlight that, there's been 111 IP addresses that have been found to have a high malicious confidence, meaning that they're likely to be bad or malicious. And we'll talk about how that evaluation is done a little bit later as well. But that's what's being shown here. Now, what do you do with these IP addresses? Well, once again, that's for you to decide. Maybe you blacklist them. Maybe you follow them. Maybe you give them additional privileges to see if they go someplace sneaky. It's up to you to decide kind of what to do with it, but the system could show you what's occurring. Suspicious login distances. This is an interesting one. What it's showing us is over the last 24 hours, somebody has logged in from 2 different areas that are pretty far apart within a 24-hour period. So we have Damon here. He's logged in from the US, and he's logged in from Egypt, which is about 10,000 miles apart, in the last 24 hours. And the system is saying, or we've configured the system to say that's a little bit strange. Now, does it mean Damon's a master hacker? No, of course not. Damon could live in New York. He could be working in the morning. He could have gotten on a flight at JFK and flown to Cairo and logged in the evening. And within 24 hours, makes perfect sense of why that's happening. On the flip side, what if you go to Damon's manager and you say, "Hey, I'm seeing this, odd behavior about Damon logging in from someplace in Egypt." And the manager goes, well, let's see, two different scenarios. The manager goes, that's kind of weird because he's in Colorado on a retreat and he doesn't even have internet access. Well, then this becomes quite peculiar. What just happened? Oh, sorry. This becomes quite peculiar. If you go to the manager or somebody in the organization and say, we see Damon's doing this, and the manager says, well, Damon hasn't been here for a month. He was let go. This becomes quite concerning. And so this is where you need to kind of put on your security hat and decide. We're going to show you a way that we do this. We're going to do this as a lab, the distance and calculations of whether or not this is legit or not. The lab is really involved and really kind of cumbersome, but you'll understand it and you get a feel for what we're trying to do when we get to it. A couple more panels here. There are many of them, but I don't know. Let's see. Here, very straightforward. Forward in that it's showing traffic. So what we're seeing are bytes received, bytes sent, and what I'm seeing here is, for at least for the bytes received, which is the purple, it's pretty low, and then it's spiking. Now, does this mean that someone is trying to exfiltrate data from our system, or maybe not, but those spikes are certainly something that we might be want to know about. And then probably the last one I'll go through over here is the firewall traffic volume outlier. And what this is showing us is volume of traffic. So we're seeing how much firewall traffic there is. And the system is letting us know with these pink triangles that there was more traffic than was expected. So there was a spike in traffic. So normally the system is expecting the range to be in this orange kind of cloud. And we see here these 4 points where it was higher than normal. Now, once again, does a peak in firewall traffic mean somebody's downloading something they shouldn't or something malicious? Maybe, maybe not. But this is certainly what's taking place and somebody should probably know about it. All right. Cool. So what we're going to do is we're going to get into the labs in just a moment, but essentially we're going to replicate some of these panels and essentially provide you with a dashboard that you can take with you. That will actually be one of the labs is taking it with you. So let's go ahead and let's really just kind of dive in here. So we're going to log into the system. If you've done this before, you kind of know where I'm headed with it. But let me go ahead and put these credentials in the chat. So we're going to go to service.sumologic.com. We're going to use the credentials or the email of training plus analyst number, and you're going to replace that number with a 3-digit number. 123-894-007, whatever. And as many of you are doing properly, you'll let me know what it is in the chat. If there's overlap with the number, it doesn't matter for today's labs. Yeah, it really doesn't matter. To go ahead and log in. The other thing I'm going to go ahead and do is I'm going to provide the labs that we're going to go ahead and utilize today. So I could show you how to get to them, but this link is just easier for both of us. So I'm pasting that in the chat. So you should get some labs. And I'm going to go ahead and log in myself. So I don't want to use the account that I was using here. I want to use a training account with the same type of account you're using. So we're on a equal playing field. So training plus analyst, I use 234. What did I do? Oh, I always do this. Service. Sorry. Certainly, if you need help, let us know. That's what Odell is here for. If you don't, that's fine as well. Looks like everyone's doing pretty good. And once again, hopefully you have those labs open as well. You can use these credentials after today. They'll be good for the rest of the month. And so they give you access, as you might guess, to our training environment. Feel free to poke around while I'm getting in there. So finally, I am logged in. Once you get logged in, you may have some tabs open already. Feel free to close those. You can go to any of the tabs and choose the option to close all tabs, and that will bring you back to the home page. So what we're going to do is we're going to use our lab guide and just start kind of rolling here. So we have 8 labs, and lab 1 seems to be a good place to start. So what we're going to do is we're going to do lab 1. We're going to do them together. I'm going to do them on my screen. You're going to do them at your device. Certainly, of course, questions feel free to ask. Yeah, kind of away we go. So what we're going to do here is first we want to look at monitoring user activity. Why do we want to monitor user activity? Well, it helps tell us and understand who and why people are using the environment. And so this is what we want to do is start to take a look at this user activity. The data is in Sumo Logic. How do we get it formatted? How do we present it to make it understandable for ourselves? Well, that's what we're going to do. In this lab, we're going to create a query and we're going to utilize AWS data. We use AWS data for most of the labs. Any other data is welcome, just that's pretty popular. And so what we're going to do here is we're going to go ahead and start to utilize the AWS data. In this lab, we're also going to, as just part of the lab, go through some parsing and go through the process of making a chart. Yeah. So what I'm going to do is I'm going to grab all the lines in step 1 and copy them and then go line by line and kind of explain what we're doing here. And I'd encourage you to do the same thing, but you can approach these labs any way you want, really. So I'm going to go ahead and copy this chunk. I'm going to go into Sumo and I'm going to do a new log search. We're going to be doing a lot of new log searches, well, probably about 8 of them. So I'm going to do a new log search and as many as I need. So I'm going to go ahead and paste my query in here. Now, I don't want to run it yet. I know this query is going to run properly, but I want to explain what this query is doing. And so I'm going to run it line by line. To run it line by line, I'm going to do 2 slashes at the front of each line, which basically turns those lines off. So when I run this query, it's as if only the first line exists. And then I'll uncomment that second line and run it. And then we'll run the first 2 lines and then the first 3 and so on and so forth. As we get to the later labs, we'll kind of bypass some of these steps because this will become very repetitive in a good way. Repetition is good, but we will kind of speed up a little bit. But let's start. So what I want to do first is I just want to look at the data. When I run this first line, I should be getting, first off, I should be getting data back, period. If I'm not, that's kind of concerning. And I should have my data down here. These are CloudTrail messages. These are messages that are in what's called a JSON format. You can recognize the JSON format because they have this, well, a few ways you can recognize it, but one of the major ways is that you can see in the log messages, there's fields and values or key value pairs already built in. So for example, here is an IP address. Here's a field called IP address. If I want to say count all the IP addresses, I can just say count by source IP address because the field is already built in here. And this is great. This really helps us with saving time when we use Sumo because we don't have to do any parsing. The parsing is built in for us. Now, what we're doing with the second line is we're taking a field and we're going to rename it. In each log message, there's going to be a user, pretty much every log message, there's going to be a user identity field. Within the user identity field is going to be a username, which is a login name. Kevin, Bob, Bill, whatever, a name. What we're doing here in the second line is we're about to parse this field. And instead of calling it user identity.username, which is where it's located, user identity, and then dot username, the dot representing a sub-nested field, we're going to say call the field actor. So now when I run the second line, I'm going to have a new field for me created called actor, and I can call it whatever I want. And now I start to see my actors. This was Kevin, this was Ankit, this was Jay Schmo, and so on and so forth. And now I'm starting to see or identify users. Now I need to go further because I need to do more than just identify users. I need to look at what those users were doing. That's what I'm going to do in my third line. In my third line, I'm going to say, take this event type. And show it. But this time, you know what? I don't want to call it event type. I want to call it event underscore type. Why? I don't really need a good reason. I guess because I like underscores versus keeping them all in one phrase. But that's what I've done here. And then on the fourth line, what I'm doing here is I'm saying, take this source IP address, display it, but call it source underscore IP. And we use that terminology frequently when we refer to source IPs. They're both correct, just that's what we're choosing to name the field. And so now we have each log message having 3 fields: user or actor, what they did, and where they did it from. And now we're starting to get data about what's taking place in our environment. Now we're not done, of course, but we're starting to get there. The next thing I want to do, and this is a weird step, but bear with me, is I want to copy this line in line 2, in step 2 rather. Now this line reads, sorry, let me go back. There we go. So this line reads event name as event name. So very similar to the event type, just the event name. And I'm going to run it just to make sure I get that event name. I'm running it basically to make sure I just don't have any typos in there. Now what I want to do here is I want to add a new line in step 5. Because I'm pulling out the information I need. I'm getting my event names, I'm getting my IPs, I'm getting my who they are, what they were doing. I'm getting that information I need. Now this next line in step 6 looks weird in that it looks redundant. This line says where event underscore type matches event underscore type. Why am I doing the same thing twice? Why? Well, the reason I'm doing this is I want to create what we call a parameter. Essentially, I want to create a filter that we're going to be able to utilize in our query. I can go ahead and say, show me where event type matches a specific event type, but I want to use a pull down, a menu type of interface, if you will. And that's what this is going to allow me to do. And so if we follow the next steps, we're going to see how we set this up. So first, we just need to have the line in there of where event type matches event type. What we're going to do now is we're going to highlight the second event type. So we're going to highlight this event type. When I do, if you notice before I do, there's nothing here on the far right. But when I highlight this event type, I have this option of create a parameter. And I want to take advantage of that. So I'm going to click on that create a parameter option. It's going to pop up this dialog interface. And I'm going to fill in the blanks. There's actually really nothing I need to do here. The only thing I need to do here is just rename this parameter to the event type. So I'm just taking that where it says parameter 1 and I'm calling it event type. Once I've done that, I'm going to go ahead and click save. And when I click save, you can already see it's starting to get set up on the over here on the right-hand side of the screen. But when I click save, I now have this filter. I can start to use this filter. If I just want to look at AWS API calls, I can say, just show me AWS API calls. Now I do need to have something in this filter. So if I have nothing, I'm going to get no results. So I want to make sure I have a wildcard or a star. Star should work. Yeah, there we go. So I need to have a star in there because if I don't have anything, the system's not going to, is looking for a null or a blank and it's not going to find it. So we need to put a wildcard. So we're saying grab all the event types. We've created a filter for event types and now grab all of them. All right, back to the lab. This lab's long. So what do we have now? We have our filter. Now what we're going to do is I'm going to grab all 4 of these lines and go through it one by one. Now, so we put in these 4 lines. Now this line here that I entered, as you notice, created another parameter. I could have just typed it in this format. I didn't have to do the highlighting and then like I did, but I wanted to show you both ways. Now, once again, the actor, a field is going to be required. And so we need to put something in there. So we're going to put a wildcard because we want to gather all the actors. We don't want to filter on them yet. We want all of them. All right, and I'm going to click start again just to make sure everything's working. I know it will, but just make sure. Okay, now what we're going to do is we need to start to count this. I now know that Mike ran an AWS API call from this IP address, but the goal of this lab is to look for the top 10 user activity. So I want to take all this data, these 688 messages or so, and start to group them and count them and see which are the top 10. And that's what I'm doing next. This line is pretty straightforward. I'm counting by the actor or by the user, their event type, and the event name. So I'm categorizing those three fields to equal one result. So here I see Kevin ran 3 AWS calls for stop configuration recorder. Kevin also ran 2 AWS API calls for create cache subnet group, and so on and so forth. So now I have a list. I have a pretty long list. I have a list of about 125 items on here or so. That's great, but I want the top 10. What I'm going to do here is use the top operator. Top is an operator. We can do the top 5, the top whatever. We want to do the top 10. What do we want to do? The top 10 IP addresses? Not really. We want to do the top 10 actors, the top 10 users. And we want to do the top 10 users by event type, by what they were doing. And then we can even add the count to the end of it. And so now what we start to see are the top 10 users of what they were doing and the frequency or count that they were doing it in. Now, the last step here is transpose. And what this transpose is going to allow us to do is just take the data and modify the view of it. In this case, we have, and I don't know if I ever use this term properly or not, but we essentially have 3 dimensions of data. We have an actor or a user, we have an event type, and we have a count. Well, we can express this data better. And that's what transpose is going to help us with. It's going to allow us to express the data in more of an Excel field with rows and columns. And so when I run this now, same data, the data hasn't changed, just it's a little cleaner. And now I can start to see, okay, Ankit was in the top 10 and did a lot of API calls and a lot of console sign-ins. Should he be? And then we could start to have those conversations. But now I'm getting that data back, and now I could send this to somebody, and here's my security report of what's going on. All right, so we should have gotten to this. We were supposed to do it for the last 24 hours. I did for the last 15 minutes. It doesn't really matter. But hopefully you got something like this. The question was event name. Where is it showing? Let's see here. Sorry, too many tabs. So yeah, it's actually, so we're actually dropping it. That's a good point. In fact, let's just kind of talk about that for a second. So yeah, good point. So right here, we're calling back the event name, but when we do our top 10, we're not including it. So there's really probably no point in having this event name here, since we're dropping from our results. That's actually a good point. This is a bit redundant because we would count by, let's just see, let's play with it for a second. Yeah, so then we have our event types and then we're counting them. Yeah, we didn't really need that event name. But we brought it along for the ride anyhow. So good question or good point. Yeah, I think we use it in one of the later labs. So I believe it does come back. Yeah, I think so. All right, cool. So the last part of this lab is creating a chart. So we have our data in whatever format we have. Let me just to kind of get to the same view. But maybe this tabular or table view is not a great way to express our data. Maybe we prefer a bar chart, a line chart, pie chart. It wouldn't really be appropriate here, but it could work. But we have these different options that are available to us. And that's what we want to point out here, was that we do have different options. Within those options, we can start to change the look and feel of the chart. So in this case, I'm using a bar chart. I can go ahead and choose the gear icon, and I can start to modify some of these options, change properties. I can choose colors and start to play around with that. I can move the legend from the right to the bottom, which some of these might not sound that exciting, but somebody requested these at some point, so that's why they're there, and many other features. So just wanted to show you that you do have some ability to modify these dashboard panels. Now, more to this lab. This lab, like I said, is a pretty big beast. What we want to do next is we want to customize the parameter with a lookup table. What does that mean? Well, here I have my parameter for my event type. And I can choose any event type. I have to type in the event type, but I can enter any event type. Let's say I want to look for AWS API call. I'm going to go back to a tabular view just for this, although it doesn't matter. Isn't that bringing anything back? Let's see, probably the typo. It does have to be the exact case. Yeah, I do have it. AWS API. So I can go ahead and add that in and search for data that way, of course. But what I want to do here and what I want to introduce is the ability for you to utilize a lookup table to access this data, populate this data so that you can select from a list of event types that exist within the data. And that's what we're going to do now. In this case, what we've done is we've created one for you. So what we've done is we've created a lookup file or a lookup table for you that's located in this address. And what we're going to do is we want to now point to it. And later, we're going to show you how to make your own lookup tables. Right now, we're just using a shared one. To use this, I'm going to go to the event type because I want to set the parameter there. Set the lookup table there, excuse me. And I'm going to choose Manage Parameter Settings. And now, like it says, I'm going to really just kind of follow the directions, but I'm going to specify that lookup file location down here. So let me show you in the actual lab or in the UI. So here is my parameter settings. I'm going to go ahead and click on the arrow for set values for parameter. I'm going to choose from this pull down the option of lookup. And then I'm going to specify the lookup file or the lookup location, which is going to be /shared/event types with an underscore in there. I then need to specify just down below that the field of the value. It's going to be the event type. So I want to use event type or event underscore type, excuse me. And that's about it. I'm going to click save. The system is now putting the two together. And now, if I go into my event type, I should have lookup available, and I do. Now I have the ability to just select one. I don't have to type it in. So saving us steps, which is good, and so making it easier for users. And so now I can go ahead and specify an event type, or once again, I can just use the wildcard to not specify one and select all. All right, last step here. There we go. Where is it? There we go. Sorry, is creating a panel. So at this point, we have our data. We have it formatted in a chart that hopefully is kind of pleasing to the eye. But now we want to save it to a dashboard because we want to kind of replicate that dashboard that I showed earlier. Not exactly, but generally speaking. So to do this, what we're going to do is it's pretty straightforward. We're going to click Add to Dashboard. When we do so, we're going to give the panel a name. And ideally, we want to give it a name that's relevant to what we're looking at so that somebody that's looking at it in the future knows what they're looking at. I'm going to specify a dashboard location. In this case, I'm going to provide a new location, and I'm going to use, as it says here, this naming scheme of SOC. And you can use kind of whatever naming scheme you want, but something sort of unique. So JB234. Yeah, that's good enough. And then I'm going to select Create New Dashboard. Now, this one I want to point out is when we click Create New Dashboard, we want to choose the old UI. So by default, this is going to be turned on to the new. And so it's going to be blue. We want to switch it to the old. The new is great. I encourage the new, but for these labs, we need to rewrite some of them. We haven't had a chance to yet. And so the old is just a little more stable, if you will. But once I have that set up, I'm going to click add. And now what I should get is a dashboard with my panel. And now I'm viewing top 10 user activity. And now we're going to create a new one and continue. So that's kind of the method for today. All right, so last lab one, I know it was a big one. Hopefully you stuck with it. Of course, if there's any questions, please holler. There is more to this. Wow, I forgot how long this lab is. What we want to do here is we actually want to add our filters. By adding our filters, what we can do and what we will be able to do now is start to filter all the panels that we have. So what I'm going to be able to do soon is when I put in a map, I can say, just show me Ankit, and it will show me only his user information here. It will show me only his map information. Oh, it's exact phrasing. That's why it keeps tripping me up there. So to add the filter, when you're in your dashboard and in edit mode, there should be just a little filter icon. And then you're just going to click add filter. Or you don't have to click add filter. Actually, excuse me, it's going to take those filters automatically because it recognizes them. Yeah. Let's see, another question about the parameter data types. Which use case do we use different type? So let's see, good question. We don't, just only because we don't go into it, but let's take a look at it together. So the question is, okay, well, there we go, is for the probably for this portion, when would you use other lookup types? And so lookup is really what you're going to use. It's really what we're going to drive you to. So the other options exist, but this is lookup's the way to go. So. All right. And then in our lab, I think there's a couple quiz questions. Let's try to get these correct. I sometimes get tripped up on these. So these are a few true false questions. So the first question is JSON field equals _ raw source IP address as source IP. What is that doing? Or true or false? Is it extracting the source IP address and all subsequent values as appearing in the incoming log files? That is true. It's a weird, the question is, it's a bit wordy, but it is true. Double curly brackets enclosing a variable label are used to create parameters. That's true. We saw that as an example somewhere around there. Question. Let's actually do this one first. And then I use the settings icon in the message tab to change the color of the graph. Well, no, that's actually a little bit of a trick question. I actually was in the aggregates tab and then used the gear icon. So like I said, a little trick question. Unrelated question is what format does the lookup file have? Or what format does the lookup have to be in? So it can be in a CSV. It can be in pretty much any. I guess CSV is probably best, but we'll take a look at a couple different versions of it shortly. All right. So let's jump into lab 2, and lab 2 is now going to be that geolocation that I referenced earlier. So why do we want to utilize geolocation? Well, I feel like it's fairly obvious, but we want to see where our users are logging in from, and are they real users, or should they be logging in from there? Are there potential data leaks or what have you? And so this is going to be quite telling and helpful for us. Now, the first portion of this lab, as I mentioned earlier, is kind of repetitive, and I'm just going to take the whole chunk. I'm going to copy it. I'm going to do a new log search, just easier to start a fresh panel. And I'm going to paste it in, and I'm going to run it. The one difference that, really the one difference from the one we did previously is we have a new field in here called result. Actually, the new field is called console login, but what we're doing is renaming a result, because this is going to allow us to look at successful logins as well as failed logins. And we can decide, do we want to look at one versus the other? And so we're starting to add this data or bring this data back, and then we can start to apply a filter to it. Now here we're going to, actually, we're going to add in step 4 and 5 these lines. So in step 4, I'm going to, well, just grab them one by one. In step 4, we're grabbing these lines of where is empty actor and where is empty event type. Now, it's not where is empty actor, there's actually an exclamation point in front of that. And that exclamation point is acting as a not. So what we're basically saying is don't retrieve data if the actor is blank. If the username doesn't show up, don't retrieve it because it's just not really helpful, especially for a lab use case. So I'm using these as filters to say, bring me only results, not blanks. Now here, I'm going to go ahead and create our parameters like I did earlier, but I'm not going to highlight. I'm going to use those double curly brackets like we just went over in the quiz to automatically create those. But once again, I need to put those stars in there for any results to come back. Otherwise, they're looking for blanks and blanks don't exist in the data. So hopefully I'm up to this stage. And if you're not, you can just take basically what's in query 7 and copy it. But what we need in query 7, if we're not taking the whole query, is just the last line. Now this last line is a pretty powerful line, and let's go over what it's doing, because this is also using a lookup table. Now, this lookup table is a little bit different. This lookup table is an internal table housed by Sumo Logic with geographic data. This geographic data is not Sumo Logic's data. It's actually a company called Newstar's data. Newstar, they are experts in geographic data, and so that's why we're utilizing their data. What we can do with their data is start to utilize the geographic data and start to isolate or locate where an IP address is from. This only works with public IP addresses. And for this line, it actually reads easier if you read it from right to left. So what's this line doing? What we're doing is we're taking the source IP, so the IP address, and we're comparing it to the IPs that exist within this geolocation table. From that table, we're not going to grab event type or event name or actor. We're going to grab some geographic information, latitude, longitude, country name, city, region. There's other geographic data as well that we can retain or bring back. We don't need all of it, but there are other values we can pull back. So when I run this line, this last line, what I'm going to have is for each IP address that I have, I'm going to have a latitude and longitude, as well as a country name, possibly a city, possibly a region, depending on if it can find that. But for this lab, I only need latitude and longitude. I don't need the other things. In fact, I don't need them. They're not helpful, but they're helpful visually, but they don't help with the mapping. So now that I have this latitude and longitude, what I need to do is count them. I need to aggregate our data. In this case, I just have a whole list of latitudes and longitudes, but I need to, like I just said, aggregate it so I can start to compile it from a math standpoint, and then also start to take advantage of the graphical or the dashboard or panels or charting features. So in order to do the aggregation, I'm going to go ahead and copy the last line. It's more verbose than we need, but that's okay. So with the last line, when I run it, I'm counting by the actor or by the user. I'm counting their IP address. Basically, I'm just grouping these together, even if they're singular groupings, but now I'm counting them. So here's one IP address or one location. Here's another. Now I want to stick these on a map. How do I do that? All I need to do is click on the map icon. Since I'm in the aggregation and I have a latitude and longitude field, the map icon is available. And now I've plotted on a map where my users are logging in from. This might be concerning, seeing somebody log in from China. It might not, but that now we can start to make educated decisions on, is this good? Is it bad? Do we allow it? Do we not? And so forth. All right, now what we're going to do is, like we've done before, we're just going to go ahead and save this map. So we're going to, or not save it, excuse me, we're going to add to a dashboard like we did previously. So once again, we're going to click add to dashboard. We're going to give this panel a name. And then we're going to want to reference that panel, that dashboard that we created earlier. So SOC JB234. I'm going to click add. When I click add, I'm actually going to get an error here, or not an error, more of a warning. What it says is filter already exists. Basically, it's letting me know, hey, you're about to create a filter with event name, event type, and actor, and you already have one in place. Now, in this case, I want to intentionally do that because I want to use that filter in 2 places, but the system's letting me know, hey, if you don't, you might need to rename one of those fields. In this case, this is all cool. I want this, so I'm going to click add to panel or add panel. And now, once again, I'm brought into my dashboard with our panels, or plural now, 2 panels. And now we have our filter that we can utilize for both at the same time. So, cool. Hopefully you found that interesting. All right, let's a couple quiz questions here. First one, lookup uses CrowdStrike data to provide latitude or latitude and longitude, true or false? So that's actually false. We use CrowdStrike data. We look up latitude and longitudes, but not together. CrowdStrike data is going to be used for threat intelligence, and we're going to look at that a little bit later soon, lab, I think 6. New Star was the where we get the lookup data for latitude and longitude, and it only works for public IPs. I can display a map without aggregating data, true or false? This is false. You need to get that aggregation step to be able to even have the map icon. And then I can use add panel to add to an existing dashboard. This one's kind of controversial because we've actually modified this a few times, but ultimately what we want you to do is when we say add panel, it's really add to dashboard. Then by adding to the dashboard, you're adding that panel. Little kind of a trick question, just poorly worded. All right, I'm going to keep going here. We'll take a break probably 20 minutes or so. If you need to take one before then, of course, please do. As I mentioned, or I was starting to, Lab 8 is when we'll actually use that threat intelligence. So I said Lab 6, that's wrong. Question was, oh wait, let's see a couple questions. A few different questions here. Let's see. Is geolocation only for IPv4? Yes, I feel pretty confident in that. Question was, how do you add to the same dashboard? So the way to do it is when you add to dashboard, you have to know the name of the previous dashboard. So the first time we did this, when we typed the dashboard name in, we had the ability to create new, just like this. Once we create that first dashboard, though, the next time I go in, I should locate my dashboard. And now it will go to that. So you need to designate. Let's see. Someone got error messages in the panels in the dashboard. One thing I would recommend you do or check, let me just show it to you. I mentioned it, but that's okay, is, oh no, hold on. Wait, I'm all over the place. Test. Come on. Is make sure this option is turned off. And I think that's why you're getting the, Luis is getting the error about the parameters. The new dashboard doesn't, it handles parameters differently, and the lab just hasn't been adjusted yet. Oh, and then there was a question, let me go back to that quiz question. Was the, so this one is false. You can't use add panel to add to an existing dashboard. All right, cool. So yeah, let's keep going here. I think I got many of the questions. Yeah, I think we're good. Okay. So lab 3. Now, what we want to do in lab 3 is we want to go ahead and, oh, wait, let me go. I just see another question. Actually, Odell, if you could try and assist. Yeah. So lab 3, what we want to do is we want to look at failed login attempts. Now, why are failed login attempts important? Well, they mean somebody couldn't get into the system. Do they mean that a malicious hacker was trying to break in and cause havoc? Or does it mean that Bob forgot his password? Well, it could be both. But we need to start to look and see look at these failed logins. And what we're going to do here is start to look at them across time and start to see how many failed logins there were. And once again, this is where you would kind of put on your security hat and see, if Bob could not log in 50 times in a row, was it a brute force attack? Or is Bob just really forgetful? Or did he create some process that he mistyped his password and that process is repetitive? Or, there's many ways to kind of understand or evaluate what's taking place, but let's have the data at least show us what's taking place to get an understanding. Now, once again, very similar first big whole chunk of lines here. What I'm going to do is I'm going to grab this whole query in step 9 and just go line by line. Most of it we've gone through already. So I'm going to new log search again. I'm going to paste it in, and I'm going to kind of comment off most of these. Actually, I'm not going to comment on most of these because we've done these before. So once again, we're pulling our CloudTrail data because that's going to show us information about logins. We're pulling the information about the actor, the result to see that they logged in successfully or not. In this case, we're probably going to want to look for failures. And that's what we're going to do in this line right here. Here, we're pulling the result. So we're saying, show us if the login was successful or not. Now, in this case, we don't care about successful logins. Successful login could be a hacked attempt, but that's just not this use case or this relevant to this use case. In this case, we want to look for failed logins. And so that's why we're saying right here, where result equals failure. Now, we could have also, I don't want to get too in the weeds, but we could have created this into a parameter over here as well, but that's a bit kind of overkill. Now that we're pulling the failures, what we're going to pull also are only AWS console sign-ins, because that's all we care about, are sign-ins and fails. And we could have flip-flopped this line. This line could have gone up here, just kind of choosing to put it a little further down. So when I run this with my stars, because remember, I need to have those, otherwise I'm looking for blanks, which don't exist. Now I'm starting to get my data. Now I see J Schmo failed to log in from this IP address at this time. And actually, I should do more data. I'm only doing the last 15 minutes. Let's do I'll do the last 6 hours just to get a little bit more data. Actually, I'll do the last 24 hours and play along like we should. So now when I run this, I should get a lot of data. More data, at least 77 records. All right. What I want to do now, though, I'm just going to wait for it to load or finish loading. That's good enough. What I want to do now, though, is I want to introduce a feature called time slice. Now, when I ran this query for the last 24 hours, I'm saying, look at the last 24 hours and show me all the logins that failed. That's pretty straightforward. That's what I asked for. It should give me that. But what I want to do here is I want to use a time slice. The time slice is going to allow me to take my data, to take my data and slice it or group it in time buckets. Specifically, in this case, time buckets of 1 hour. So rather than looking from yesterday to today, I'm going to look at how many failed logins did I have from 12 o'clock to 1 o'clock? How many failed logins did I have from 1 to 2, 2 to 3? And now I can start to put these time groupings together and start to see, oh, in this time grouping or this time slice of 1 hour, a user had 2 failed logins. In this other one, he had 40 failed logins, and start to evaluate and make decisions based on that. So here I'm introducing the time slice as an operator with a value. And now I'm going to count. And I'm going to count by that time slice, as well as by the user and all this other stuff. And once again, as somebody pointed out earlier, we don't really need all this stuff because the event type is only going to be AWS console, but it's in the lab, so we'll just kind of live with it. But what we should get now is when we count this, now we're starting to see these groupings. So now I see from 2 p.m. to 3 p.m., Jay Schmo could not, sorry, this one. And this one, Kevin could not log in twice from 12 to 1 p.m. I can click on the count to start to sort it from high to low. Or what I want to do really specifically here is have the system do that counting for me, an organization. So once again, I'm going to use that top operator and say me just show the top 10. So now when I run this, it's going to take a little longer since I'm doing 24 hours, but that's okay. Now it's going to look for all the actors, all the groupings, all the time slices, add them up, keep the top 10 and drop the bottom, whatever. And it should even sort them by count once this is finished loading. Yeah, I'll continue while it's loading. I want to just wait for it to finish. And so that's what we get from here. And now we can start to see these. Let's go back to the lab because we're not quite done. Actually, we are. Yeah, that's all we're doing with this, that lab. So what we now have are our groupings. They're sorted, or they should be. This is processing. And then we can, once again, post that to a dashboard. So now, once again, we're going to add to dashboard. We're going to give this a name. We're going to save it to that same dashboard that we created earlier. If we created a second one because we had problems with the first one, then we'll save it to the second one, but hopefully to a dashboard that's working. And then we're just going to click add. And now, still get this because once again, we're reusing those filters. And so now we see these. All right, let's see. Okay, and that's it for that lab. Quiz questions here. So adding a wildcard to the parameter window means it will filter out everything. True or false? That is false. It actually will include everything, which is what we want it to do. So a little tricky, but time slice groups my incoming logs into chunks of time. True or false? True. Yeah, I'll leave that true. Let me show you why I'm hedging just for a second. I just in transparency, if we're going to teach it, let's teach it right. When I run this time slice 1 hour here, it doesn't do anything until I do the count by time slice right here. So while this operator is grouping the times, I'm not displaying those times until I display it right there. So just a subtle thing. I mean, basically it is true, but just wanted to kind of throw that in there. And then this content of where exclamation point is empty actor, does that filter out logs that do not have an actor? Correct. So if there's a blank actor or null, or exactly, it leaves them out. So that would be true. Okay, great. Let's see. Time-wise, we're doing pretty well. So let's do one more and then we'll take a break. And then once we get back from break, we'll kind of fly. So now lab 4, excuse me, is a little bit of a continuation on lab 3, in that we want to look at account compromise from brute force attack. A brute force attack, for those of you who don't know, is when a hacker will force a mass amount of passwords or logins at one time. So they might know a login is jbreltime@sumologic.com. So they'll try password 1, password 2, password 3, password 4, number 4, 5, 6, and all these, and eventually one of them might hit, and that would be the brute force. So what we want to do here is we want to start to look for or try to identify brute forces. Now this lab, the data isn't great here, so you'll see a little issue when we get to it, but it's still effective. Just it doesn't show it as blatantly as I'd like it to, but it's still a good lab, so that's why I want to teach it. So what we're going to do here is, like we've done before, is we're going to go ahead and use pretty much the same top query. So if we're using step 9 as the whole query, the first half, we've seen before. I'm going to grab the whole thing though and talk through it like I've been doing, and I hope you're finding this to be helpful or effective. So I'm going to do a new log search. I'm going to paste the whole thing in, and then I'm going to comment off those lines that I want to just talk about more specifically. So the first bunch of lines, AWS data, pulling those actors, those users, the event type, the result. We're going to use the parameters and put those wildcards in there so we get results back. Remember, if we don't, that's going to be a problem. Now we want to use our time slice. Now, as I mentioned before, here I'm using the time slice, but I'm not using the results of the time slice until down here. And that's fine, but just want to point that out. So if I run this line with the time slice 1H, the results are exactly the same as if I had that line in or not. It doesn't change the results that I view until I get down further to call those results. Now here, what I'm doing, if you attended our search mastery class, you've seen this behavior. If you haven't, that's fine. What I'm doing here, though, is I'm looking at the result field. The result field is only going to be a success or a failure. I might know that, I might not. In this case, I do know that. And so what I want to do is I want the system to look at each log message, create a new column called success count, and based on if the result is a success or not, tally a 1 or a 0. A 1 for a true, a 0 for a false. So when I click start or run, I now have a new column called success count, and I'm either going to have a 1 if the result is a success, or if I have a failure, I don't want to spend too much time looking for one. Well, there's got to be a failure in here somewhere. I don't know. We're about to see. If there's a failure, I want to do a failure count. Oh, I need more time. That's fine. So here, this was a success. We see a 1 for the success, a 0 for the fail. And if I can find a fail, perfect. In a failure case, I have a 1 for the fail and a 0 for the success. Now what I can start to do is add them up. And that's what I'm doing in this next line. I'm saying take the successes and add them up. Take the fails and add them up, but add them up by actor and time and event type. Since I'm doing sum, I'm now doing an aggregation, and now I get my results in an aggregates tab. And now I'm starting to see by our buckets, Suraj successfully logged in 18 times and failed to log in once. Jay Schmo logged in 9 times successfully, no problem, no fails, and so on and so forth. Now, where I was saying this data is not as great as it could be is we actually wanted, this would show a lot better if these numbers were reversed, if we had a lot of fails and no successes. But in this case, we're showing the opposite, unfortunately, which is probably more of a real world example. You wouldn't have somebody forgetting their password 1,000,000 times, but you might. Now, in this case, remember, we want to look for fails. So I'm going to add this next line of where failures are greater than 0. In this example, if somebody did not log in successfully, I don't care. In this case, I want to look for fails. If somebody logged in successfully every time, that's not what this report is about. Now, it could be somebody has stolen credentials and they logged in successfully every time, but that's, once again, not what this is about. This is about looking for failed logins. So we're going to say, just show us where failures are greater than 0. That's going to then get rid of those that had no failures. Now what we want to do is we want to figure out an apples to apples. Here, although some of these are pretty clear and obvious, here was someone logged in successfully 18 times and 1 failed login. Here, they successfully logged in 82 times and 2 failed logins. Which is better? Which is worse? Well, what we're going to do is we're going to create a failure percentage. And this actually is, yeah, this should work. So when we create this failure percentage, now we're starting to see, in a moment, this person had a 5.8% failure rate. This had a 2.4. This is good. This is bad. And now we're starting to be able to compare. And we could say if they had a very high failure rate, if it was above over 90%, we go to their manager or talk to them or do whatever we do. So what we want to show here is the ability for you to utilize these this Boolean logic, as we call it, this true false to start. Well, it's not Boolean logic, but this true false to start to utilize in a tally system. Now, there are other ways to get the same results. We could have, we encourage you to do it this way, but we could have done something where we counted the successes, not with a tally system, but just counted them in a different format or different way. Like I said, with Sumo, many ways to do the same thing often. And now, once we've done that, as we've been doing all day, we're going to go ahead and add the panel to dashboard. So once again, add to dashboard. You kind of know the steps. Give it a better name. Courses, and then locate your dashboard. And then just click add. It'll probably bring up that warning message about the filters again. We're going to ignore that or approve it because it's acceptable. And now we have panels. All right, so let's take a little break. I know that was kind of fast, a lot of info, but good questions by you guys, and then hopefully you're sticking with us. I think you are. I feel like you are. So we'll take let's do I can do a full 10-minute break. We got enough time. So we'll do a 10-minute break. During that time, I'm going to, like you should do, grab a little snack, stand up, stretch, all that. If there's any questions, of course, leave them in the chat and we'll come and grab them when we come back. But otherwise, we'll come back. We'll do a few more labs. They'll be pretty quick, and then we'll take the exam. So thank you, everybody, and see you in 9 minutes or so. All right, everybody, welcome back. Sorry about putting that alarm. Usually try and turn it off about a second or two before it hits, but I didn't. So, but what we're going to do is dive back in and kind of finish up. So we had just finished lab 4, which was the brute force log. Yeah. Lab 5. So lab 5's quite a lab. For this one, we're going to show a lot of in the weeds stuff. You will probably not replicate this specific query ever. You might, but you probably won't. So there's some things that we're going to show you that really might be just too technical, a little kind of in-depth, but we'll still get through the lab together. And what I want you to do conceptually is understand what's going on, which we'll go through pretty clearly, or hopefully pretty clearly. So what is this lab? This lab is all about, as it says here, detecting a land speed violation. What is a land speed violation? Well, a land speed violation is when a user logs in from one location, then logs in from another location during a time period that is not practical. So for example, if somebody logs in from the US and then a few hours later logs in from Australia, that is not technically possible. And so that is a land speed violation. When I worked at Google, we used to call this the Superman issue, kind of the same idea. Unless you were Superman, you couldn't go ahead and fly from one place to another. Now, absolutely, if they're using a VPN, this becomes irrelevant, but we can only help so much. So yeah, absolutely. But this is assuming non-VPNs. We can't get around that. So what we want to do is we want to have the system start to calculate what is acceptable and what isn't, what is normal and what isn't. Now, this is going to be especially tricky because we are dealing with a globe, a sphere. The world is spherical. I don't think I'm breaking any news there, but as a result, it's not a straight line. There's curvature and all these type of things. And what we're going to show you is a operator that allows the system to calculate that and work with that curvature. Now, once again, that curvature of the Earth is not something you're going to deal with all the time, but you certainly could use a square and copy it and take advantage of it. So let's go through this. As it shows here, we're going to use a lot of different operators, and many of these that we're going to use, we're not going to go too in depth to. For example, IPv4 to number. It's in the steps, but it's just not where I want to focus our attention to. So let's go through it. Of course, questions please ask it, but let's take a look. And this flow chart is showing us what we're about to do through code. And as you can see, the flow chart's kind of involved. So what are we going to do? What are all these steps that are involved? Well, first, we're going to need to select our source category. What set of data are we using? Are we using CloudTrail data? Are we using Apache data? Well, we need to define that. We need to parse the user and the IP address. So within that set of data is going to be a user or an actor and an IP address, and we need to extract those and pull those out. We want to filter out null addresses. If it's a null address, we don't want to include it. We only want valid IP addresses. So if it's blank, that's not good. Like the is empty with the exclamation points, kind of same idea. Now, here's where it gets kind of crazy. What we need to do, or what we need the system to do, is create the start of when a user logs in. So we need the system to say, okay, this is essentially time 0. Then the user logged in from this IP address and another IP address during a particular time period. So it's starting to, like I said, kind of do a time 0. We're going to filter out single logins. If somebody logs in once during a 24-hour period, that's not relevant here. They need to log in at least twice in order for us to even determine if it's possible or not. One login is certainly possible, of course. Then what we're doing here is we're going to convert our, well, I actually don't even kind of mention here, but what we need to do is we need to take the IP address and convert it into a decimal format. And then we're actually going to turn it back. And this is just one of the artifacts of making sure the IP addresses kind of show up properly. You'll kind of get it. You'll see it. It's not a step you'll use very frequently. That's why I kind of want to rush through that one step. It's just not applicable much. Then we're going to do a geo lookup for each IP address. So we're going to have these IP addresses. And now, like we just saw with the geo lookup operator, we can start to see, okay, this IP address was Africa. This was the United States. Then we're going to use what's called the Haverstein formula. Haverstein formula, not a sumo logic thing by any means. This is the formula that involves the curvature of the Earth. So in any field or profession, if you ever want to calculate the curvature of the Earth, Haverstein formula is probably what you're going to use. Now, once we calculate the distance, we need to calculate the speed a user would need to travel. We see somebody logged in from Africa and 3 hours later logged in from the US. In my mind, I don't think that's possible. But if it was, how fast would they have to have been going? Probably pretty fast. We're going to filter out logins from the same IP address. We want to look for different IP addresses here. And then what we're going to do is specify what we call the impossible speed. We are going to say that anything over 500 kilometers per an hour is not possible. So if somebody is traveling faster than that between Australia and Africa, that's not possible. And therefore, there's an issue and it's a land speed violation. And once again, we're going to format for presentation. We want this to look presentable. So let's go ahead and start grabbing portions of the query. The first two lines are really the first line or two. In step two, oh, and you may need to log back in. It's been a few minutes since we've been in there. So go ahead and log back in with those training credentials you were using earlier. And that password is Feb 2022 exclamation point. So once we're logged back in, we're going to do a new log search again. We should have portions of the query already saved. And so we're going to start to paste it in. We're going to use CloudTrail data again, because that's really good data to show us where users are logging in from. And then we're using these fields and we're modifying the name. So we're taking the user identity username. We called it earlier actor. In this case, we're going to call it user. And then for the IP address, we're going to call it just IP. When I search, I should now get field values with IPs and usernames. And now I start to get them. Even if that has a blank username, it's still going to retrieve it, which is fine for right now. Next, this whole thing is actually kind of useful. What we're going to do here is we want to filter out public IP addresses. The lookup table, or just the lookup in general for latitude and longitude, cannot work for private IP addresses because they're private IP addresses. Public IP addresses can be associated with location. And so what we're doing is we're saying, start to look for the user and create a time of when they log in. So we're looking for where the user matches the user. We're saying only look for public IPs. And then right here is where we're starting to say, set this min message time. So where we're starting to say, keep a tally, essentially. Once again, a little bit in the weeds, probably overkill, but still useful. I'm going to paste it in. I'm going to go ahead and run it just to make sure I didn't put a typo, which is reminding me I need to have a parameter in there because I have my curly brackets. And so now I'm starting to look at Siraj, the IP address he logged in from, and the time. And this time is represented in epoch time, it's called. So it's just a different method of time where it starts from, I think, 1970 on January 1st, and each second is it counts as a 1 and just tallies it that way. Not a sumo logic thing either. But it's starting to give me my times. Now what we want to do is we want to filter out IP addresses. Or actually, well, two things here. Excuse me, take that back. We want to go ahead and convert the IP address to a number. And then we're going to display that previous IP address with that previous login time. So what we're starting to do here is we're starting to go ahead and create our starting points, as well as start to attribute which IPs are going to be associated with that. So I'm going to go ahead. Here. I think that's right. Let me try this again. I think I just copied and pasted incorrectly. Okay, cool. So here's what we have. We have our IP address, our first IP address with the starting time or a login time. We have our IP address just expressed in a decimal format. And we have our previous login time. And so now we're starting to see this login time, And we're starting to see, or starting to gather that information of when they occurred and where they occurred from using the IP. Now we're going to do the geo lookup in a moment to really get that information back. What we're doing here is we're taking that decimal and we're turning it back to an IP. It seems redundant. It is. It's really just an artifact of this specific lab. But basically, we're taking our IP, where is it? Here it is, sorry, our previous IP, and we're just turning it, we're displaying the octets. Now here's where we're going to get into the geolookup and the speed. So now for each line, we have an IP, we have two IPs. Now we want to start to utilize the geolookup and look at physically where these are. So what we're saying here is do a lookup for the IP and then do another lookup for the previous IP. Now, when we get this back, we're going to start to get country 1, country 2, and latitude 1, latitude 2, and longitude 1, longitude 2. So now I'm starting to see, for example, let me see if I have a good one. So here's one right here. Here, an individual logged in from China and logged in from the UK. Now, is that possible? Of course it's possible. Now, what we need to start to do is add in that time to see how fast would that individual have had to travel between the two. And ignoring the fact that Great Firewall of China and all that. So this is where we use the Haversine formula or function. And so what it's doing is exactly as I described, not very well, but it's determining the distance with latitudes and longitudes in kilometers. So we're going to be stuck with kilometers, so US centric, but no miles per hour. We could, of course, do a calculation to take the kilometers and then multiply them to turn them into miles if we want to. But we're going to run this Haversine line. And so what it's going to do is take the latitudes, take the longitudes, figure out where they are in the world or where they are on the globe, and start to figure out how far apart they are from each other. So now we have where somebody logged in, who logged in, where they logged in from previously, and how far apart those two places were. And we could start to make educated decisions. If we see somebody logged in, once again, from the US and China, maybe that's weird because it's in a 24-hour period, or maybe it's not, but we can start to kind of make these decisions. But we want the system to help us with it. And so this is where we're going to have the system calculate the speed a user would have had to travel. So we're going to go ahead and take the login time, the previous login time, divide it by 303,600,000 seconds per an hour, which is then going to give us our hours. How many hours difference is there, or delta time? We're then going to take the distance. We're then going to take the time, and now we get a velocity. And then we're going to say, show us where the velocity is greater than 0. If the velocity is 0, where somebody logged in from the same place twice, that's not really helpful. We want different places. And so there would have to be a velocity in order for that to occur. And as you see, it's just, query's getting longer and longer. There's a lot going on in here, but now we have these apparent velocities. Now this one, for example, here is saying this user traveled from the United Kingdom and Indonesia. The time difference was 0.001 seconds, so 100th millisecond. Now, is that possible? No. At least I think. But to be sure, the system is telling me if it was possible, the person would have had to travel 6 million kilometers per an hour. That is not possible, and therefore this is kind of weird. Once again, VPNs throw this all out of whack. So now we want to take this all and just clean it up a little bit further. What we want to do here is we want to add what we're calling a suspicious speed. easy to say. In that we know it's not possible to go more than 500 kilometers. So only show me where the apparent velocity is greater than 500. If it's less than 500, that's possible. So let's see, I might even be able to find an example of one that is possible. Let's see here. Let's see. I don't know. No, these are really pretty fast. So all of these they're going a little too fast. 600, and this one would have had to travel 700 kilometers for this to successfully happen. And so let's paste this next part in. Now we're only going to see those that are suspicious. And then finally, we're going to format it. So what we're doing here is we're going to format the presentation. As you see, we have just a kind of a big mess of rows of data. We're going to clean it up. We're going to go ahead and take the IP and the previous IP and concat, put them together. We're going to show the country names, either both country names, or if it's the same, one country name. We're going to show the user, the IP address, etc. And so, like I said, we're really just kind of cleaning this up for formatting, which is important because we want it to look good. And so now what I get is something that's a little more pleasant to read. Here's Mike. He logged in from Singapore. He logged in from the US. Those are 12,000 kilometers apart. And he logged in 0.00002 milliseconds. That's not possible. He would have had to travel 46 billion kilometers an hour. That's not right. What's going on, Mike? Just see if there's a, let's see what's the closest one. Yeah, so these are all. All right. Yeah, so that's the query. Once again, like I said, it's a very robust query. It's very in the weeds. The parsing where we're changing an IP to a decimal and back is something you probably will never do. That being said, I'm glad we showed it to you. Hopefully you understood conceptually where we were going. And that's really kind of what I wanted you to get out of the lab. So hopefully you were with us for that. Let's see, let's do these quiz questions. True, false once again. Geo lookup receives an IP address and returns location. I'll go with true. It returns latitude and longitude and get a location. That's good enough. City, country name, there's a variety of different fields to return. So that's true. The Haversine formula was used to convert the octets to decimals. That's false. The Haversine was used for the curvature of the Earth. The octets to decimal, which once again, we're not going to use very frequently, but somebody's probably going to ask about it, was done through what's over here, this IPv4 number and backshift operator, which is not also just not used very much. And then finally, land speed violations allow you to detect suspicious user activity. True. They should be taken with a grain of salt, of course, because as we've mentioned, VPNs could make it not suspicious, but true. All right. Lab 6. Lab 6 is going to reintroduce lookup tables. We're going to get a little bit deeper. We're actually going to create our own, which I think will help understand them. Of course, doing it is the best way. So how do we add a lookup table? Well, here's how. Once again, I'm going to grab the query, copy and paste it in, and talk through it. All right. So what we want to do here is we want to create a list of users or actors as we're referring to them. Because when we have that pull down, that filter that we've been utilizing in our dashboard, at this point, it's not populated. I can go ahead and type in a specific user, but I need to know that user's name or identification. It's also case sensitive. What I want to have happen though is I want the system to populate this. And so that's what we're about to do. So in the first line, we're going to look for CloudTrail data like we've been doing all day. This CloudTrail data works great here, and that's the source we're using. The next line is I'm taking that same line that I was doing earlier and looking for that actor or that user. So parsing out that user once again. I'm just going to run it just to make sure my data is returning. Now what I'm going to do is count by actor or count by user. I'm doing this for, well, one major reason is because I want to get to the aggregates page. I want to get the results of my data. And now I have the results. Now the results or the count I don't care about. What I want to produce is a list of users or actors that are in the system. I don't care if they've been in one time or a million times. I just want to count them. I want to tally them. What I'm going to do on this fourth line is I'm going to say remove the count field. I don't need it. This count field is not relevant. Like I said, if they showed up once or 143 times, that's equal to me. So I'm just going to say remove it. And that's what this line does. It removes a field. And so now I should just have a list of actors or users. I do. And now what I'm going to do is save this to a lookup table. I'm going to use the naming convention here. And I'm going to specify JB. I'm going to do 2345 just because I think I have an old one in there. I want to make a new one. So I'm going to use this naming convention. I can share it if I want to, or I can save it to more of a private location. And I'm going to click start. When I do, I'm going to get this message about asking me, do I want to run this query? It says doing so will result the data being saved, which is the whole point of what I want to do. So I do want to do this, and I'm going to click run. It's going to take 5 seconds. It's done. I guess 0 seconds really. And now it should work. Now what should work? How do I know it works? What we can do is we can then run a cat command, and what we should see are those users. So let's test. New log search, cat, space, whatever location you use to save it. And actually, I'm going to go ahead and paste this in the chat. You should be able to access mine as well, since it's shared. So you can kind of check me to make sure I'm doing it correctly. When I run this, though, what I should get are those 13 or so users. And I do. So now I have a lookup table that has these users defined in them. Now what I want to do is I want to go back into my lab and I want to tie that lookup table to that parameter setting. Remember earlier when we first did it, we did the shared event types. Now we're going to go ahead and do it for actors. So what we're going to do, as it says here, we're going to go into our dashboard and we're going to open one of the queries. It doesn't really matter which one. It really doesn't matter which one. Once I'm in it, I'm going to go to the actor parameter. I'm going to click on the 3 dots. I'm going to go to manage parameter settings. I'm going to go ahead and select under the set values parameter, the down arrow, and I'm going to choose that lookup option. And now I'm just going to specify where that lookup file is. You can use mine. You don't include the cat in there, but the shared. You can use mine. I can use yours, whatever. And now I'm going to specify, like it says here, the field that I want it to be called. The field that already exists in there, and it's called actor, and the user is actor, and that's, I want to use the name actor again, so I'm just going to select actor. And then I'm going to click save. Once I do, the system's going to kind of tie everything together. Might take a few seconds. But now what I should get if I go to my actor and delete everything is I now should have all these fields available to me. What I'm also going to do here is choose the option of update dashboard. And I'm going to choose the last 15 minutes. I'm going to keep that original time frame. And it should, let's see, it should bring me in there. I didn't automatically pop it in, but now if I go to my filters and I go to my actor, let's see, it didn't save yet. What did I do wrong? My actor, update dashboard, that's 15 minutes, apply. Should work. Oh, let me refresh. I don't want to dwell on this too much. Let's just try one. Yeah, I don't want to go. Well, let me go through real fast just again and see if it pops up. It should, and hopefully it worked properly for you. In fact, I'm more concerned it worked properly for you than me. So shared. Actor, save. And then update dashboard is what I want to do. See, so there it is. Let me just try one more thing, and then if I don't want to, like I said, I don't want to dwell on this too much, but I do want it to work. Sock JB 234 add panel filter actor. There we go. Cool. And now when I go to my actor, now I have all those options, and now I can just select Ankit. And once again, I don't have to worry about spelling or anything like that. So cool, and good to see some of your others of you. It's working. So sorry for a little tangent, but I wanted to get it right. So good. All right, I believe that's it for lab 6. Yep. So let me just make sure. Yeah, that's it for lab 6. So quizzes to display a lookup table, use the command CP. That's false. You want to use the command for cat, CAT. Search parameters allow me to pivot quickly to any metadata values. True, assuming you set them up properly. And then I use the save operator to create a lookup table, and I believe that was true. We used save right there. All right. Lab 7, I'm kind of going to skip over. I'm going to discuss, but I'm kind of going to skip over. In that, what we want you to do, ideally, is now you've created a dashboard, specifically a dashboard for AWS data. You can now export this dashboard to a JSON format and then import it back into your own production environment if you're using CloudTrail, of course. Now, you would need to make some modifications, which is what the lab has you going over, because, for example, if your source category is probably not labs AWS CloudTrail, so you would need to change that. So what this lab has us doing, and like I said, I'm not going to do it. If you want to, of course, please do, but just to save a moment of time, basically we take the dashboard, we export it. It exports in a JSON format, and then we take that exported file and we would just use a text editor to look for the source categories, and you would rename them to your source categories, save it, and then you would just import that JSON. And now you would have in your production environment a dashboard that you can take away. So if you can take it away and utilize it, please do, of course. I'd love for you to use this thing that you built, but want to at least show you the steps and the idea that you can do so. All right, I want to go to lab 8 because I want to spend time on lab 8. Threat intel is important. It's kind of one of the main reasons we're here today is threat intelligence. So I want to make sure we go over this correctly. So what we're about to take a look at is, as I said, the word a few times, threat intelligence. We looked at geographic data earlier, and that was that new star data with the latitude and longitude. We're going to look at CrowdStrike data now, which is threat intelligence data. It's not going to be latitude and longitude. It's going to be threat related. And so that's what we're going to be able to access. We have in this lab activity, we introduced the idea of scheduled views. You may be familiar with them. You may not be. If you are, of course, that's good. If you're not, that's fine. But what the scheduled views allow you to do, or allow the system to do, is essentially run a query in the background. So this query, whatever this query might be, and we're about to look at one, is running in the background of the system every minute. And every minute it's running, it's grabbing the results and bringing them back, and then running and grabbing the results and bringing them back. Why this is helpful is we can then utilize the results from that query. Now, the results are delayed by essentially a minute, but that's usually okay, especially for a lab activity like this. So what we're going to do, and you should be able to follow along with this, you should have permissions, is we're going to go to the go into Sumo and go to the black bar. If you don't see the black bar, it might be hidden. Select the black bar. Go down to manage data, and then go into logs. So manage data, logs, and then we should see a scheduled view, scheduled views. There should be specifically a scheduled view called IP threats. And here it is. What I want to do here is I want to go ahead and there's a few ways to do this. It's the same end result, but I basically want to grab that query. So what I want to do is I want to click on IP threats. There's going to be a query down here, and I want to copy it. Then what I want to do is I want to go into a new log search like we've been doing all day and just paste that query in and let it run. We're basically just stealing that query from there. I think we want to run it for more than the last 15 minutes, but it's good enough just to get some data. Now, what is this data that we're getting back? Well, this is the CrowdStrike data. So let's start to take a look at this. And I should have probably commented off a bunch of these lines. And so many of these lines we don't need. It's really overkill. This big middle portion is just a chunk of nothing. But let's take a look at this. What we're doing here is we're looking at data. Are we looking at CloudTrail data? Are we looking at Apache data? In this case, we're looking at everything. The wildcard says bring back all data. Once we retrieve that data, what we want to do is we want the system to identify IP addresses. And we're using regex here. This is an alternative method for parsing. We cover this in our search mastery class. Regex is not a Sumo logic thing. It's used in Sumo logic, but we did not invent it. We don't want credit or blame for it. But basically what we're doing is the system is looking for IP addresses. It's looking for IP addresses that are not 0.0.0.0 or 127.0.0.0.1. If those IP addresses show up, those are not valid, or at least valid for our use case, and so we want to ignore those. Now, here is the line where we're doing the lookup. Remember previously we were doing lookup, latitude, longitude, etc. And I told you to read it from right to left, and the same applies. Now we're going to take our IP address, and we're going to compare it to the field called threat that exists within the Sumo CrowdStrike database. From that database, we don't want to grab latitude and longitude. We want to grab type. We want to grab actor. We want to grab raw, which is just another field. We want to grab a field called threat level, and this field we're actually going to rename and call malicious confidence. We then want to look for IP addresses, and we want to only have those results that have a malicious confidence. A malicious confidence is essentially, I think I kind of mentioned it earlier, CrowdStrike's evaluation of something being scary or not. A high malicious confidence means it's probably malicious. A low malicious confidence means it's probably not. Unverified, don't really know because threats have to start somewhere. So this is starting to give us a feel for that. And the rest of it is really just formatting. Once again, what we're doing here is then we're introducing the time slice. We're grouping our time slices together. And what we're showing and bringing in is source category. And ultimately what we're getting here is now we have our time period, which is a 1 minute window. So what we know is from 5:39 to 5:40, this IP address showed up in our logs. This IP address has a high malicious confidence, meaning it's probably bad. We don't know what actor is associated with this. Now, this is not user actor. This is CrowdStrike actor, which might have names of various nefarious things. And we get some more information, things about kill chains, IP address types. But most important, not most importantly, but very importantly, we see the source category here. So what we're now understanding or being told is in our guard duty data, this IP is showing up. In our security hub data, this IP is showing up. Now, and it's potentially a little scary because it's marked as malicious. Now, this is where we would once again decide what to do with this. Do we blacklist this IP address? Do we follow it? Do we, whatever? And that's what we're starting to get from here. So we're starting to see when it occurred, who it occurred, who it occurred with, or which IP, and then potentially what it was. So for here example, a Wizard's Fire, and where, and count as well. All right. Let's see. All right. So at this point, what we now have is we have a list of, I just mentioned it, so I'm not really going to repeat it, but basically we have our IP addresses, we have our groups, our users, et cetera, et cetera. All right. What we want to do now is we want to introduce the idea of outliers, which hopefully are not new to you. If you've been using Sumo before, the idea of outliers is something you're aware of, but if you're not, let's introduce it. So I'm going to grab this whole line or these lines and copy them and talk about what this does. This feature is really important. And I'm going to comment these off just to go line by line. So what we're doing in this first line that I copied is we're actually getting rid of a whole bunch of fields because I don't really care about them. What I want to look at now is I basically want to see how many, well, let's show you. Let me remove the fields that I don't want and we'll see what's left. I'm going to get rid of a whole bunch of fields. And basically what I'm left with is how many malicious instances appeared during a 1 minute time period. So from 539 to 540, there was one act of maliciousness, I guess. Act of maliciousness, I think is all right to use. Here there were two, here there were two, here there were two, et cetera, et cetera. Now, if there were two, is that concerning or not? I mean, it sounds scary, 2 acts of maliciousness during a 1 minute period. It sounds kind of scary, but maybe that's a normal amount for my traffic. I want the system to tell me if that's a lot or not. And that's what outlier allows me to do. It allows me, or allows the system to start to determine what's normal and what isn't. I'm going to count by time slice, which I thought I did already. Here we go. So what I'm now there, these are really the numbers I wanted, the better, higher numbers. So now what I'm saying is 2,000 acts of maliciousness during a 1 minute period, 1,800 acts of maliciousness, and so on and so forth. Now, once again, if I tell you 2,000 in 1 minute, is that a lot or a little? It appears to be a lot based on just these numbers here, but I don't really know. I want the system to tell me. What I'm going to do with this very last line is utilize the outlier operator, which is an operator in Sumo. This portion is math. I'm going to refer to it as math just for a few minutes, just calling it math and kind of generically giving it that label. But when we run this, what's going to happen is the system is going to use the math and start to determine what is normal and what isn't, based on previous times, previous windows of time, previous results. And what we start to see is the system formulating what's normal and what isn't. At 540, we had 1,700 acts of maliciousness. The system has determined between 1,300 and just about 2,400 is considered normal based on previous results. 1,700 is within that range, and so that's considered good or normal or acceptable or kind of whatever adjective you want to use. I'm going to make one change here. I'm going to modify this threshold to a 2, which is going to give me better results that are a little more illustrative. Or it should, at least. Let me see. Yeah, these results are a little bit better. Let me just let it finish loading here. Okay, so for example, it's still loading, but that's okay. So here in this first time or the second one, we see the actual, we see the range, and that's considered normal, acceptable, or what have you. Now here, if we go further down, the range has changed based on previous results, the system just doing its calculations. And now the system is saying between 1599 and 2194 is normal. Well, 1520 was the actual, and so that's considered abnormal. It's below what's considered normal, but it's still outside the acceptable range. What I want to do though is I want to express this a little bit better visually. I want to select the line chart option. When I do, let me get more data in here. Oh, it's still loading. There we go. Now what I see, I think it's still loading as well, but that's okay. But what I'm starting to see is the blue line representing the amount of, like I said, maliciousness I had in a 1 minute period. I see this light blue cloud representing the upper and lower threshold based on the math. And then I see the pink triangles representing the outliers, those times where the results of maliciousness were abnormal. Now, in this case, and it's still loading, but it should just be about done, I see examples of maliciousness that's higher than normal, as well as lower. I might not care about lower. If I have less than normal, that's not really scary to me. Having more than normal is. This direction allows me to control that. By saying plus, minus, or one or the other, I can say only show me those things that are above normal or below normal. And so I'm going to modify that here. I'm going to remove the minus because, like I said, I don't care if something's less than the normal level. I just care about more than. I'm going to rerun it. It's going to take forever to rerun it yet. Not forever, because there's a lot going on in here. Yeah, there it goes. Now the threshold here allows me to start to modify my standard deviations, which is where it gets very mathy, and the documentation covers it in much more detail than I will. But essentially, we can start to say, show me things. Let's see, it's just taking a while to load, unfortunately. But by changing this, it's going to change the outlier calculation and change the range of what it considers to be normal or not. And so what I can do is I can start to fine tune that range and say, am I being alerted too much? Let me reduce one of these values. Am I not being alerted enough? Let me increase one of these values and start to find kind of that sweet spot. So the outlier is really an important feature in Sumo Logic. I don't think I'm really truly doing it justice here, because what it's going to allow you to do is start to set up rules and alerts so that you can be notified when these things happen. And so now the next time you have more maliciousness than you expect, you can get an email and then do whatever action you need to take. It also allows for the ability to have the system be dynamic in its evaluation of what's normal. If I was to go ahead and say, why don't I just say, put in a rule that says if I have more than 2,000, that's bad or scary. And I could. The problem is that's not going to grow dynamically. If my traffic grows 10x in a month, that 2,000 might not be scary. 20,000 might not be scary. But the system will grow with it in its dynamic versus being static with a single value. And yes, as the group was a question, so this is essentially deciding how many standard deviations if you want to use. And this is where it gets mathy, but essentially, if you remember probably high school math, you have your bell curve, and that's the standard deviation, and then that whole thing. So yeah. Let's get back into the lab because I think we're just about done. Yeah, we are. So let's go through the quiz questions. Of course, if there's other questions, let me know. I think we're kind of up to date on them though. Let's see. So the quiz questions. You can check these are true, false. All incoming public IP addresses for possible malicious intent using our embedded CrowdStrike, and this is true. For those of you that don't know, CrowdStrike is its own service and is quite expensive. I think it's 30 or 60 grand a year, and we give it to you as part of your package. So yay us. When using the outlier command, if you set the threshold equal 3, that sets the standard deviation. So there was just a question in the chat, exactly that. So yep. Data doesn't count against ingestion when using pre-aggregated scheduled views. This is kind of overkill because you're not really going to be quizzed on that, but it does. So here's the scheduled view, and so sorry, I forgot what the question was. Yeah, so run the stored aggregate results, and so here's the question. I'm sorry. The pre-aggregated scheduled views do not count against your data ingest. And so what we're asking is, does it count against your ingest? And the question is no. All right, so that concludes the labs. I know we were a little accelerated there. I apologize. I was just kind of eager to go with these. So thank you for hanging in there and sticking through them. Hopefully you found them beneficial. What we want to do now is we want to pivot to the exam. So if you've already done an exam with us, you kind of know where I'm headed with this conversation, and feel free to start it on your own. But if you haven't, let's go through it together. So the first thing we'll want you to do is log out of the training account. We don't want training analyst 234 getting credit for the exam. We want you to. So we want you to log in with your Sumo account, and you all should have one, a personal or private or excuse me, not private, personal, professional account. Go ahead and log in with that. Once you've logged in, you should be brought to the home page by default, or if not, get there, and then click certification. Once you click certification, you're going to go to get certified. And this is where all the exams take place. Let me get into there first, and then we'll actually talk about something else. So once you get in there, actually, let me log out. I need to use my own professional account to show the exam. So I apologize for that. I forgot that not forgot it. So I'm using my account. There you go. I apologize for that. So certification, get certified. And what you should have that I did not have was a get certified section underneath this portion here. So once you get to this new page, there should be a get certified. There's also recorded live training. So if you want to go ahead and listen to some of our previous sessions, they're in here. We don't have all of them yet, but many of them are in there. We're going to select get certified. And then we're going to select the exam that we're interested in. Today's exam is Cloud Security Monitoring and Analytics exam, should be on the top row. And so we're going to click on that. You are going to register. I have registered. The registration is just going to give you some basic, really basic guidelines, and I'm about to talk about those guidelines. In fact, I'll talk about them now. So the exam is going to take, you have 60 minutes to take it. You're not going to need all that time. You do have it allocated, but it just won't take you that long. It's going to consist of 22 questions, and you need a 70 to pass it. So what, 17 right or so. It is open book, as many of our other exams are. They're open book, open resource, open documentation, and we encourage you to use the documentation. You'll find all the answers in there. So you'll read this little blurb, you'll click next. You'll start the assessment. You'll take the exam. You'll click next. You'll do better than I did. And when you do better than I did, it's important that you click submit. If you don't click submit on the screen, you don't get credit for the exam, which is not, well, one, it's not your fault. It's not really our fault. It's the testing environment, but it's important that you do click submit here. So just make sure you do, please do. Now, go ahead and start. Of course, if there's any questions, let us know. But as a reminder, you also are going to be rewarded. So I'll put this email address in the Slack. But as a reminder, once you're done with the exam, done with the certificate, well, done with the exam and pass, get their certificate, go ahead and send that to that email address. Include your email address, which you probably will, and include your job title, and we'll send you that Uber Eats gift card. So that's pretty much going to conclude for today. We're going to be here for the exam. Odell and I will be on mute, but we'll hang out just in case there are questions. If there are, please, holler. But other than that, thank you for attending. Hopefully you learned a little something today. You're going to get fed, which is good. And, thank you for joining us. So I'm going to put myself on mute. Once again, any questions, please shout. I'll leave this screen up as well. But thank you again, and best of luck on the exam.